Okay, let's give you a practical example of software evolution. This slide shows the evolution of Windows operating system. We can see that we have two main branches. We have MS-DOS-based Windows on the top, and then on the bottom we have Windows NT branch. So the beginning of the evolution of Microsoft Windows operating system can be identified in the 1st of September in 1981 when Interface Manager for Microsoft Disk Operating System project started. MS-DOS, or Microsoft Disk Operating System, was Microsoft's previous operating system that had no graphical user interface. For the sake of complete evolution, we should actually put in also the MS-DOS evolution. However, for the sake of simplicity, we will only focus on the Windows-based operating system evolution in these slides. So the development of Microsoft Windows operating system started in 1981, and Windows 1.0 was released 4 years later. Windows 1 was Microsoft's first attempt to implement a multitasking graphical user interface-based operating system on the PC platform. 2 years later, Windows 2.0 was released, and it had a nice feature which allowed graphical user interface windows to appear on top of each other. You can see this on the bottom of the figure, where the clock is now allowed to appear on top of control panel. Apple actually sued Microsoft for this feature, but Microsoft won the lawsuit in court. Windows 3.0 was first widely successful Windows. It was a good competitor against Apple and Amiga. It improved performance, memory management, and utilized improved solutions of Intel's 286 processors. It also had loadable device drivers and many other feature improvements. Windows 95 was really big for Microsoft. The first 2 years it became the most successful operating system ever. It integrated the previously somewhat separate Windows and MS-DOS operating system. The older Windows were really the DOS extension shells that were sold separately. Windows 95 could be considered as the first true Windows operating system. It featured things like plug and play, device installation, and a new user interface. Windows 95, however, had big problems in networking. Internet had started to appear, and also home computer users wanted to browse the World Wide Web. But in Microsoft Windows 95, the network drivers were really unstable and the system would often crash while browsing the internet. So Windows 98 improved the networking, it improved the stability and hardware support of Windows 95. Windows 98 was followed by Windows ME or Millennium Edition. It was to be a quick one-year project, a sort of a stopgap between Windows 98 and Windows XP that would then merge all the users from the MS-DOS based Windows to the Windows NT based Windows. As we can see from this figure, Windows ME ends the life cycle of MS-DOS based Windows. Furthermore, Microsoft only sold the Windows NT based Windows and migrated all the users from Windows ME to the next version of Windows, that was Windows XP, released in 2001. So, what happened in 1988, or actually sometime before that, was that Microsoft realized that the DOS-based Windows, shown top of the screen, had so big limitations that they could no longer be fixed. So it was better to start over from scratch. Throwing the MS-DOS based Windows away was exactly what has been said by Fred Brooks a long time ago regarding software development. Plan to throw one away. You will anyhow. This captures the idea that once you build something for the first time, you are very likely to make mistakes in the beginning that cannot be fixed in the end. This is very true for software development. Okay, so starting from 1988, Microsoft started to work on MS Windows NT operating system, with the first release named Windows 3.1 coming out in 1993. This was not really very successful, but the next version, Windows NT 4.0, was already widely successful and used in many companies. Windows 2000 offered many stability benefits and user interface benefits. Windows 2000 offered many improvements in comparison to Windows NT. But the real success came with Windows XP in 2001, as it allowed to throw the MS-DOS-based window away. With Windows XP, Microsoft was able to merge both the home users and the business user on using the same operating system rather than having different branches for them. Okay, since Windows XP, the evolution of Windows has continued. There was Windows Vista that was not so high commercial success. It was followed by Windows 7 and Windows 10, which is the current version they are selling. The cost of Windows NT evolution can be estimated to be $30 billion. It is based on Seattle Times interview with Microsoft, where they said that cost of MS Vista was $10 billion. As we know that the evolution of Vista, which is the Windows NT based operating system line, started in the late 1980s, and Vista is the fifth version of Windows NT. We may guess that the total cost of evolution is 30 billion, and probably even more, given that since then Windows 7 and Windows 10 have also appeared. So using this 30 billion as our base number, we may ask the question, does software evolvability, software maintainability, software modifiability make a difference in software evolution? Those are all characters that make software easier to develop and maintain. To figure this out, we can enter in some numbers. So according to Bundy and Rombach, where comparison of two functionally equal systems was performed, it was found out that adding features and bug fixing took 28 to 36% more effort in the less maintainable system. In another paper, industrial regression models estimate that 25% more cost can be attributed to poor software evolvability and modifiability. So, less maintainable Windows NT platform would cost 9 billion more to the company. So, taking care of software evolvability has important economical consequences. Another very important factor from the evolution you should understand, and from the evolution of Windows NT that exemplifies the software evolution processes, is that the lines of code tends to grow. So for Windows 3.1, it was estimated that there was something like 3 million lines of code. With Windows NT 4.0, it was estimated to be 16 million. With Windows XP, it is estimated to be 40 million lines of code. More source code size visualization can be seen on the website you see on the slide. We can see, for example, that the simple iPhone game app has maybe roughly 10,000 lines of code, which is the same amount of code as in Unix 1.0 published in 1971. The scale is here on the top, 100,000, with 1 indicating 100,000 lines of code, which is met with Photoshop 1.0 software published in 1990. As we scroll down, the scale changes, and this starts from 1 million lines of code. Linux kernel 2.2 is depicted here, and we can estimate from the figure that it would have something like 2 million lines of code. Scrolling down further shows that Windows NT 4.0 would have over 10 million lines of code, similar to the Android mobile device operating system. Finally, on the very bottom, we can see Google, all internet services, with 2 billion lines of code depicted in here. You can also see that mouse is depicted in here with total DNA base pairs in genome and estimated to be equal to 120 million lines of code. I'm not sure how the mouse was estimated. I have absolutely no expertise in biology, so you might take this number with the mouse line of code analogy a bit carefully, I would say. Okay, so what have we learned? We have learned that there is a huge amount of source code available, produced in the process of software evolution of these different companies. We have also learned that due to this big code base, the maintainability and the evolvability of the software makes a big economical difference.